Hey, welcome everybody. My name is Mark Medeiros. I am the Senior Manager of Community Engagement at Peninsula Open Space Trust, and thank you for joining us for today's webinar with Saved by Nature founder Richard Tejeda on the fish of the Peninsula and the South Bay watersheds. Before we begin, I would like to acknowledge the people whose territories we are joining from. Considering post-working area, I'd like to acknowledge the Muwekma Ohlone tribe, the Amamutsun tribal band, and the Ramaytush Ohlone. Wherever you are, please pause to acknowledge the native people whose territories you are joining from. Feel free to shout out their names in chat. And remember that the next step after acknowledging these communities is to learn more about how you can support them directly. So, for those of you who are new to POST, in the video, we mentioned 75,000 acres. Well, that video is a couple of years old, and we're up to above 80,000 acres of protected land in San Mateo, Santa Clara, and northern Santa Cruz counties. Much of this land is now part of our regional public open spaces, a lot of the farms that we've protected, watersheds, of course, and we're working on a variety of issues, wildlife, public access, local farm preservation. But cutting across all of this is watershed protection and a lot of work around our local creeks and streams. So today we're going to be talking about the awesome fish that we have in those creeks and streams. And before we begin, I would like to acknowledge some of the partner groups for today's webinar listed here, starting with the San Mateo Resource Conservation District. They use very diverse means to protect, conserve, and restore natural resources in San Mateo County. And we'll be talking a lot about their work on Pescadero Creek and elsewhere today. Also mentioning the Monterey Salmon and Trout Project, which we will be talking about as well. They were founded to address the problems of declining and not anadromous, for messing that up, anadromous fish populations of the Monterey Bay area. And they run a fish hatchery and have been working all through San Mateo, San Benito, and Santa Clara counties to restore fish populations. And lastly, I'd like to mention our friends at the Friends of Stevens Creek Trail. We won't be talking too much about Stevens Creek Trail specifically or the creek today, but it's a great organization to know about if you're in the Cupertino area and are interested in this whole topic and looking for ways to support a local creek near you. So today, our speaker will be Richard Tejeda, founder of Saved by Nature. This is a South Bay nonprofit that works to provide all community members with equal access to environmental education and nature. Saved by Nature works to expose, teach, and enlighten people of all backgrounds and abilities through environmental education and working collaboratively with partners to ensure mental, physical, and spiritual healing. In addition to founding Saved by Nature, Richard is a very experienced naturalist, having worked with organizations like state parks, Santa Clara Valley Open Space Authority, the Monterey Bay Salmon and Trout Project, and many others. And I'm very excited personally to hear about his knowledge of fish, because that's a particular passion of his where he's particularly knowledgeable. So with that, I'm going to welcome Richard. How are you doing, Richard?
I'm doing fantastic, Mark. Thank you so much for having me today. Really excited to be here.
I'm super excited for this. We've been working on it for a couple of weeks, and I know you have a lot of content, so I'm going to turn it over to you in a second. But I wanted to just ask, I know that fish is a particular subject that you're passionate about, and how did you get so passionate about fish?
Well, one of the reasons I started Saved by Nature is because nature did save my life. And the way that it saved my life was through positive hobbies. I needed things to fill my time, and one of the main things that I did, or the first things I started to do, was fish. I learned to fish along Coyote Creek, started at Hellier County Park, and from there it led to hiking, it led to camping, it led to the Sierra Nevada, and me learning about salmon and trout, and hooking up with the Monterey Bay Salmon Trout Project. So angling was the gateway or the door for me.
That's great. And so now you're doing all this work with these partners to conserve local fish populations. That's so awesome. So I'm going to add your slides now. And with that, going to turn it over to you.
All right, great. Well, perfect. Well, here this slide here, I just started with this beautiful photo because it just reminds me of just a different place. But the fish and the anadromous species we're talking about today makes you think that indeed we are in a different place, a different watershed, even in a different state. So let's go to the next slide. So the things that we're going to be talking about today are a little bit of the history and species, biology, the dynamics of a healthy stream ecosystem, and restoration. Now, keep in mind that this is only, a 45-minute to an hour-long presentation. This is a presentation that we can go into depth in, but today we just want to get you excited and inspired about our local watershed. And so I'll be doing my best to cover on a lot, but just know there's so much more to cover in this topic. Next slide, please. And so let's go ahead and start with a little bit of the history and some of the things that got me excited about ichthyology, or fish, if you will. Next slide, please. And so let's start with Zephactinus audax, right? And so this is one of the first fish species of teleos, which we're going to be talking about different fish species in the South Bay or the Peninsula, but I wanted to start back with their ancestors, give you a little bit of a backstory. And so this is a 20-foot long predator, if you will, and the head was as long or longer than that of a grown grizzly bear, and the jaws were deeper in proportion to their length. The muzzle was shorter and deeper than that of a bulldog, and the teeth were all sharp, cylindrical fangs, smooth and glistening, and of irregular size. At certain distance in each jaw, they projected 3 inches above the gum and were sunk 1 inch into the jaw margin, being thus as long as the fangs of a tiger, but more slender. 2 such fangs crossed each other on each side of the middle of the front. Besides the smaller fish, the reptiles no doubt supplied the demands of his appetite. And so if you look into the stomach of this, I believe this is a 13-foot long specimen, you'll see a 6-foot long specimen of a different fish species inside. And it's thought that this species actually cut a organ while it was being swallowed, and thus that's how this fish died. And so we're going to be, again, these fossils date back to the early Triassic, but they diversified around the time of the Cretaceous. Next slide. And so again, the fish we're going to be talking about are from the teleos, and the teleos fish make up most of the fish on our planet, if you didn't know. And so more than 27,000 species. And so if you look at this diagram here, this is just a way to interpret a lot of verbiage into different families and how those species sit compared to this teleos fish family. And as you can see, they make up the majority of our fish on this planet. And the difference between these fish are they have a maxilla, which is an upper and lower mandible or jaw that allows them to protrude that jaw. And so that is part of their evolution to be able to be a predator, and what makes them different than other fish species. Next slide. And so here we see, I just wanted to show you that teleos fish species are known to be more than 300 million years old. And so that you can see where the salmon species sit on this tree, if you will, or on this diagram. The salmon species is younger, about 225 million, like evolving around 225 million years ago. And so, but the species themselves go back 100 million years ago, being some of the earliest fish species, such as the Pacific lamprey, before they evolved and with the maxilla, before they were able to had a mouth as a predator. They were different, and so we'll be seeing some of those fish species later on. Next slide. And then one of the cool things about these, some of the species that we see today, is that they evolved around the same time as some of the birds and mammals that we're familiar with today, about 120 to 60 million years ago. So although they're known to be over 300 million years old, some of the species that we're familiar with seeing today did not start to evolve until the time of some of the birds and mammals that we're familiar with today. Yes, and so just wanted to give you that so you understand that that they are some of our oldest species. And when we talk about jawless fish, we're going back 550 million years ago. And so really old fish species, and some of the first species or are the first fish species on our planet. Next slide. Excuse me, some water. And so California biodiversity is really you know, I can't say enough about California biodiversity. I mean, you can be down at Anza Borrego Desert State Park and up at Jedediah Smith and have two different, you know, experiences. And here in our area in the San Francisco Bay, we do have a cold water fishery and we do have a warm water fishery. And the difference between the two is that they support different types of species of fish. But just know that some of our native species have evolved to some of our warmer waters. And you will find native species as well as non-native species in warm water as high as 80 degrees. And then some of these teleos fish, such as the pupfish found over at Anza Borrego Desert State Park, can you know, be in waters as much as 100 degrees. And so these fish themselves are very adaptable. But here in the Bay Area, again, we do manage cold water and warm water fisheries. Next slide. And so, but today we'll be talking about specific species, and I wanted to teach you about some of these species as well as some of the anadromous species that live in our watershed. So, so let's learn about some of the creatures that live here. And so today we'll be focusing on the stillhead rainbow trout, which is Oncorhynchus mykiss irideus. The Chinook salmon, which is Oncorhynchus shah-isha, and the coho salmon, which is Oncorhynchus kesuch. And the watersheds that we'll be discussing are the Guadalupe River watershed, which has the stillhead rainbow trout and the Chinook salmon, and Pescadero Butano Creek watershed, which has the stillhead and coho salmon. So let's take a look at these watersheds really quick, so to orient you on where and what we'll be talking about. So let's start with the Guadalupe River. So the Guadalupe River starts at Mount Umunhum, which means resting place of the hummingbird, and named after the chief of one of the tribes in the area. It then flows through Guadalupe Creek into the Guadalupe Reservoir and then down into Almaden Lake Park. This is where it's very important because this is where Los Alamitos Creek and Guadalupe Creek go into Almaden Lake, but make the Guadalupe River. The Guadalupe River flows down to an area over near the Guadalupe River Park Conservancy, where I had the pleasure of working for 6 years. And there is a species in a restoration area, so you can find Chinook salmon and stillhead rainbow trout in that vicinity. The water then goes down past the airport and past Yulistack Natural Area and into Albizo Marina County Park, which is brackish water now, a mixture of fresh and salt, before moving out into Don Edwards, our largest refuge in the Bay Area, and one of our largest refuges, and I believe the entire nation, before flowing underneath the Golden Gate Bridge and out to the Pacific Ocean. And this is important when we begin to talk about the anadromous journey. And so we can see that it's an inland watershed. But then when we look at the Pescadero Creek, we see that that is a coastal watershed. And the Pescadero Creek slightly starts off at a place I was fortunate to work at, and that is Portola Redwood State Park on the western boundary. It then flows into another place I was fortunate to work at, and that is Where was that at?
That was a Pescadero Creek Park.
There was one in between that, Portola. Oh, there was Castle Rock, Portola, and then Pescadero, and then Memorial Park. So it flows through all of those parks before flowing down near Highway 1, and there is the mouth of Pescadero Creek. So it flows through lots of different owned properties by state parks and also by the city and also by the county. And so much different where this is off of the coast of the Pacific Ocean and then the others in the Inland Bay Area. So those are the two watersheds we'll be talking about today. Now I want to let you know about the species because this program is about the different fish species that you can find. Now the reason why I have this knowledge is many reasons. One is because I really have a passion for, our local waterways. Another is because one of the responsibilities for me is to educate people about salmon and trout. And so I created a wildlife page. And in that wildlife page was every fish species that you could find in the Guadalupe River. So this is years of knowledge, but also some research. And so I want to introduce you to these species so that you can understand some of the river ecology and what's going on with some of our salmon and trout, and that they're not the only ones that live in our waterways, and that they're not the only ones that have, to compete for resources as well. So let's go to the next slide. And so on the Guadalupe River, you can find an array of species, right? From non-native to native. If it has an asterisk, that means that species is also found in Pescadero Creek. So right now we're talking about Guadalupe River. This is the western mosquito fish. You may see this fish in a lot of our waterways, put in there by valley water to make sure that they eat the larvae of the mosquito. And that's why we're not being bit up all the time, living in inner city next to all these waterways, right? We have the beautiful California roach, which is a native species that not many people know about. It only grows to be about 4 inches long. It's a beautiful little species. The three-spined stickleback is found in the Guadalupe River, but a coastal three-spined stickleback is found in Pescadero Creek, which is a subspecies of the three-spined stickleback. Another amazing, beautiful, really tiny 4-inch species that is just a beautiful evolution. And what I mean by that is if it's found in the ocean, underneath it'll have a spike, but if it's found in the river, it won't have that spike. And that's a part of its evolution as well. I won't touch too much on it, but let's go to the next slide, please. Lots of fish to talk about. The riffle sculpin, the coast range sculpin is found in Pescadero, while the riffle sculpin is found in the Guadalupe River. We have the golden shiner, which is non-native, the threadfin shad, which is non-native. Next slide. And a lot of these that I'm sorry to tell you that a lot of the fish that you grew up knowing so well or remember catching as a kid are non-native. They don't necessarily belong here, and they do compete with our native and non-native species for resources, being the green sunfish is non-native, the black crappie, the bluegill. Next slide. The red-eared sunfish, the white crappie, and the black bullhead are all non-native species. Next slide. We have the white catfish, the brown bullhead, and the channel catfish are all non-native species in the Guadalupe River, and they are found. They're found here. Yes. Next slide. The smallmouth bass, the largemouth bass, which is also found in Pescadero Creek and a predator to a lot of our salmon and steelhead, larva and fry and par. The Sacramento hitch, which is a beautiful native fish, it grows to be 14 inches. Now, a lot of these fish that you're going to see that say Sacramento is because there was once an ancient river that came from the Sacramento area. Well, the Sacramento River kind of didn't go into into the San Francisco Bay. It went into the Monterey Bay, and that's what cut the canyon in the Monterey Bay. That's why you find the same fish species that you find in the Delta as you do in the Monterey Bay. And so that's what we're talking about, one of them being the Sacramento hitch. Next slide. Another being the Sacramento pike minnow, another species growing to be 14 inches, and the Sacramento blackfish are native, and the Sacramento sucker, which a lot of people, don't think are too aesthetically pleasing and all, but, they're all native fish, and they belong here and have evolved through hundreds of thousands, if not millions of years. Next slide. The hardhead is another native. And then we get to the Pacific lamprey, one of our oldest fish species, again, dating back to 550 million years old. It is a fish species, and it was, before they evolved into having that maxilla, that upper and lower mandible. And so it's a incredible species. This larva stays up to 7 years in the gravel. It's anadromous, moving back and forth from fresh water to the ocean, and you can see a wonderful segment on river monsters. We have the common carp found both in Pescadero and Guadalupe River. Next slide. And then we get into some, what I like to call our all-stars of the watershed, and that is the rainbow trout slash the central California coast winter stillhead, which is found both in the Guadalupe River and also in Pescadero Creek. The difference between the two we'll talk about a little later. The Chinook salmon is an amazing species. It's found in the Guadalupe River, and it can grow to be, in our rivers, maybe up to at the max 45 pounds. But in Alaska, they can reach over 110 pounds. Green sturgeon have found their way into the Guadalupe River and been stranded until high water have arisen and allowed them to out-migrate back into the bay. Next slide. And then some species, because Pescadero Creek is near, Highway 1 and closer proximity to ocean water, we do have some different types of species that can only be found in Pescadero Creek and not the Guadalupe River, being the native Pacific staghorn sculpin, the prickly sculpin, the starry flounder, next slide, and the yellowfin goby, and one of my favorite, the tidewater goby, because it's only about 2 inches long, and it's only found in the tidewaters between the estuary and the ocean. And so it's an amazing area. If you didn't know, 95% of our estuaries have been turned into parking lots or amusement parks, and so the species very, it's under a lot of pressure. And then we also have in Pescadero Creek, and only found in Pescadero Creek, not the Guadalupe River, is the Central Coast coho salmon. Once again, Oncorhynchus kesuch. Next slide. And so those were the fish species. Again, we have a lot to cover in a short amount of time, so we're going to be moving pretty quickly. But as you can see, there are a numerous amount of fish species in the Guadalupe River and in Pescadero Creek, native and non-native. A lot of our non-native species, a lot of people don't realize that in the 1930s were planted by the Department of Fish and Wildlife as a fishery enhancement program, not knowing that these species would become invasive, if anything, which some are. So the difference between the non-native is a non-native species may be there, not have a detrimental effect on the environment, while while invasive species will have an impact on the ecology, such as a largemouth bass or striped bass eating, the babies of the salmon and trout, right? And so let's go to the next slide. We'll be talking about some of this biology. So the biology, the difference between a stillhead and a rainbow trout, if you didn't know, is that a stillhead rainbow trout is genetically encoded to go to the ocean and come back. It's born in fresh water. It then migrates to the ocean and then migrates back. We don't know necessarily what does that, but it's one of the reasons why they're prized so much by anglers, is because a fish that is 4 years old, that lives in fresh water, will only grow to be 4 pounds, while the same fish as a stillhead that migrates to the ocean will return as 9-pound fish. And so, they can grow really big, up to 20, 25 pounds, actually, the stillhead rainbow trout. And so again, the difference is a rainbow trout will spend its whole life in the river or creek or stream, never making its way to the ocean. 2 stillhead can make a rainbow trout after mating. A rainbow trout and a stillhead can make a stillhead. 2 stillhead can make a rainbow trout. We don't know what makes it happen, right? Biologists, they need to work harder. Chinook salmon. Again, is our meaning the king salmon, right? The Chinook salmon found here in the Guadalupe River and also in Coyote Creek and Los Gatos Creek as well, can grow really big. They're our largest of salmon species and most prized of salmon species because of their size and for their food capabilities and things. But anyhow, we do have the wondrous king salmon here, and then the coho salmon, which is thought it's in my opinion, our prettiest of salmon. It likes smaller, flatter coastal watersheds, and when it does migrate out to the ocean, it stays closer to the continental shelf, and then it'll migrate back into its stream. And so in Pescaderos Creek case, they must be very beautiful because they have a very short distance to navigate from the Pacific Ocean into Pescadero Creek. So I can't wait to see some video, some spawning coho in that creek when it does become available. So next slide. And so what draws them is our Mediterranean climate here that we have. We have warm, dry summers, cool, wet winters, and 90% of our rainfall does occur between November and April. So if you didn't know, the fishing season is actually closed from November to April, and that is to protect them. That's inland, and that is to protect them during that time from November to April. Our fish start to migrate into the Guadalupe River as early as August. Our Chinook salmon, our steelhead start coming in as early as October, and this is through years of experience of understanding how these fish work and move through our system, right? And so that's when they start to come in. But as you can imagine, from November to April, it's when we get 90% of our rainfall. The fish are very smart. They've evolved to understand it. They move under the cover of darkness, and they also move under the cover of the rain and of the high waters. They don't want to come in when the waters are really low because they can be seen by people. They get picked off by predators and things like that. Right? Every river is different, though. And then we just have some different salmon species and what they look like in their different spawning colors. Next slide. And so again, the migration happens about August, and it's just an amazing thing. It really is. So again, for example, if they're born in the Guadalupe River, they're going to be born, and the female is going to come in. Well, we can talk about steelhead and talk about salmon. Okay, so the difference is that steelhead are idiroparous, and salmon are semiloparous. Idiroparous means that steelhead can spawn more than once, and semiloparous means that salmon can only spawn one time and then they die, right? Steelhead can spawn more than one time, and they move back and forth from the ocean to the river, okay? So, but they all kind of have the same, they do have the same life cycle, if anything, but except they die at the end of spawning. Salmon do, and steelhead don't, okay? They start off as eggs. So a female is going to move in as early as August, the female, and she's going to look for a nest. She's going to lay on her side, and she's going to begin to dig that nest with her caudal fin, right? She's going to use that big fin, and she's going to fan that fin as she lays on her side, and she's going to clean out the sediment from the 1 to 2 inch noyo rock. It's about the size of my fist. And then she's going to deposit her eggs into that when a male comes in, and they sit in the ovate position, and they're side by side, and they swim right next to each other, right? She cleans out that nest. She goes to deposit her eggs. He moves right in back of her, waits for her to deposit those eggs into the gravel, moves right back next to her. They both quiver, open their mouths. She releases the eggs, and he releases the milt, which is the same as sperm, and it fertilizes the eggs while the eggs are in the noyo rock, right? They start off as egg, as you can see here, and then after about 30 to 45 days, they're going to turn into eleven. From then, they become a fry, a par, a smolt, and smolt is very important, right? Because in the egg, eleven, fry, and par stage, they live in the fresh water as little babies, fresh water. But as smolt, if it's a steelhead, well, actually, if it's a salmon, something in the brain's going to say, you got to move to the ocean. But if a fish moves, I should have had my salmon puppet. If a fish moves from fresh water to ocean water, what's going to happen? The fish will die. So it needs to stop in the estuary, right? Such as estuary at Pescadero off Highway 1, such as the estuary at the County Marina Park that we showed you, right, on the flyover on the Google Earth. Those estuaries are very important because that smolt has to stop there to acclimate. It's going to memorize all the home smells of its river. It's going to change psychologically, physiologically inside. Its organs are going to change, allowing it to adapt to that salt water. Then it's going to move out into the bay underneath the Golden Gate Bridge, or it's going to move out from Pescadero into the Pacific Ocean. It needs to stop there and smoltificate. Very, very important, right? And then it becomes an adult. Let me show you what they look like, the actual size. So here we see that Water temperature is very important. It plays an important role on when the eggs hatch, and we'll be talking about that a little later. So we see that the eggs are clear, they're not fertile, but once they become eyed eggs, that means that they were fertilized, and they're going to be eyed eggs about 22 days. And then the elevin begin. That yolk sac is their food for the next 30 to 45 days. And then they absorb that into their body, that yolk sac, which is their food. And then they become fry, okay, after about 100 days. Those are the fry, and they become par, and they become smolt. Move out to the ocean, come adult, and they move back. Very tiny fish. Permeable, meaning water can flow through them. Interesting. All right, so migration, life cycle, start off as an egg, they migrate as an adult. They have to stop on both ways. On the way out, they have to stop and acclimate. On the way in, they have to stop. And now they're getting used to the freshwater. The only difference between the two, again, is that the salmon only spawns once. The male and female, they will die afterwards, right? The steelhead will spawn, and then it'll move its way back to the ocean to come back, right, after protecting the eggs. Okay, so semiviviparous, heteroviviparous. All right, next slide. All right, so dynamics of a healthy stream ecosystem, right? And so we wanted to talk about this. Mark has a great idea as well, and it's because we have to understand, what makes a good river, what makes a bad river, because a lot of us have grown up inner city, and we see a lot of channelized rivers. We see a lot of rivers that have been engineered by the Army Corps of Engineers, and we don't really understand the way a river is supposed to look anymore, or the dynamics it's supposed to have. So let's talk about some of those things. Next slide. So what makes a good habitat? Well, when you're up in like the upper watershed, and you're in an area and there's no houses around, and you're kind of like, whoa, this is beautiful. That's good habitat. When you see woody debris, trees down and logs in the water, and submerged leaves and aquatic plants, and you see a riparian zone. A riparian zone is like the small aquatic plants, and then like a shrub, and then a understory tree, and then an overstory tree. You see the different layers here in the photo where it says dynamics of a natural stream ecosystem. That riparian corridor is very important because it's what cools the water temperature, allowing those eggs that I showed you to hatch. The cooler the temperature, the faster they'll hatch. The warmer the temperature, the longer they take, making them more susceptible to predators. It also increases dissolved oxygen. We breathe oxygen through our lungs. They breathe dissolved oxygen. They extract the dissolved oxygen using their gill filaments in their gills, right? I want gills. Okay, sorry. All right, so increased dissolved oxygen. So the shade cools the water, increases the dissolved oxygen, make happy fish. And fish can breathe, right? With no dissolved oxygen, they're going to be all stressed out and they can't breathe, It also, the submerged leaves and the terrestrial trees, the submerged leaves provide for macroinvertebrates that are aquatic in the water. The terrestrial trees not only provide for shade, but they provide for terrestrial habitat for microinvertebrates like stoneflies, mayflies, dragonflies, and the things that fish eat, like you may eat, well, you don't eat McDonald's. I use that for the kids, but you may eat Wingstop, and fish eat macroinvertebrates. All right, so they like stoneflies, mayflies, but without having a riparian zone, we wouldn't really have the fish food for them, and the fish wouldn't be able to survive, and they wouldn't be able to live through their different life cycles. Like as being a fry, they need those little small aquatic insects, right? But then we look at environmental impacts, and we all know. And we're not going to, be doom and gloom and go into all of the things that, are involved in making a good habitat a bad habitat. We all know what happens in inner city areas, such as 75% of our salmon spawning habitats has been lost. Dams and barriers. I did a report on removing the Guadalupe River, the Guadalupe Dam for Guadalupe Reservoir. And it would have exponentially grew our salmon trout populations by the thousands by opening up extra spawning habitat by removing that dam. So dams and barriers, what did the fish say when it couldn't swim anymore? Dam. water diversion for human use, right? So that's very for agriculture. You know, there's a balance there. Riparian zone encroachment. So when you walk up to a river, it either has a buffer zone or it has a building, you know, 10 feet up to that creek, and that's not good. We need a buffer zone for our fish. We need a buffer zone for the trees and the plants, and we need a buffer zone for the environment and for the wildlife to do its thing. And that's very, very important. And with population growth, well, ours started during the time of the cattle, actually, in Spanish, and encroaching on and wiping everything out. So sort of the Spanish, and then the Mexican era, same thing. And then we started agriculture with the Valley of Heart's Delight, got even worse. And then we started just building on everything, right? And so a lot of our waterways have been lost, okay? And then also overfishing, and then our estuaries again have been lost to development. And a good example is the San Lorenzo River, which was one of the top 3 fisheries in California. But after they built the Santa Cruz Beach Boardwalk parking lot on top of the estuary, it pretty much, you know, collapsed. Yes, next slide. And so what makes a river a river? Well, you know, it's not a channelized thing. A river should have riffles, it should have eddies, it should have tailouts, it should have a pool, and it should have a run. And all these are very important in the life cycle of a salmon and trout. Very, very important. So if you didn't know, salmon and trout, during their life cycle, when they're eggs, they need a specific area. When they're elevin, they need a specific area. When they're fry, when they're par, throughout their life cycle, they need different areas. They can't just live in one area, or else they'll become susceptible to predation. They won't have enough oxygen, won't have enough shade, won't have enough shelter. There's just so many parameters that are different between a pool and a riffle. In a pool, a larger fish can survive. It can be feeding in a riffle, and then if it gets scared, it can go into the pool for protection. But without these things, it's just not gonna, you know, without these different, you know, dynamics in a river, then the fish are not gonna be happy. It's just not gonna happen. When you channelize a river, you're literally killing that river and anything's ability to live in that river by taking the meandering and the life out of that river. And so we shouldn't do that. Yes, next slide. All right, so cool. So looks like we're doing great. And so I want to show you a Chinook salmon off of the Guadalupe River. Here's a fish. Remember I told you they lay on their side. She's cleaning her. This is a female, and she's cleaning that nest. That quick little movement there. I was walking when I worked at the Guadalupe River Park Conservancy, and I said, I'm going to look off this bridge and see a salmon with 2 of my coworkers. And I looked off that bridge. And it must have been all my hard work over the years because I saw that fish. And she was cleaning out a red bed, and it just made my day with all the years of education. You know, just, I don't know, it had nothing to do with me, but it was just beautiful to see that female digging her red right there in downtown San Jose off the St. John Bridge next to the Shark's Tank. It's just an amazing feeling. Next slide. And so here is last year, Chinook salmon on Los Gatos Creek in Campbell, around the corner from my home. I live in Campbell off of Highway 17. I like that quick step over to the Santa Cruz Mountains and Santa Cruz Beach. And we have numerous spawning salmon here, Chinook salmon, as you can see. Just a beautiful sight in downtown Los Gatos. And just can't say enough. And we did a program called Seen the Fish Walk. I can't remember, but anyways, it was a great program. We took the public out to see these salmon, got them excited about them and seeing them. And one of them has a circle on the side of its body, and that circle signified a Pacific lamprey catching a free ride. You might see it in the, yeah, but anyway, what happened was the adult Pacific lamprey somewhere along the way, maybe in the ocean, attached itself to the salmon, because lamprey don't have fins. They didn't evolve yet. Remember, they're so old, they didn't even evolve yet to have fins. So they they'll use their little circle mouth, attach themselves to an adult salmon and catch a free ride up the river and then detach. And so one of these salmon actually has a big white circle that I kept pointing out to the group saying, look at that Pacific lamprey was attached. It was so cool. Anyways, next slide. And so here is a good buddy of mine, Roger Castillo, the same gentleman who found the Colombian mammoth along the Guadalupe River, the same gentleman who found the Chinook salmon and first, let people know about the Chinook salmon on the Guadalupe River. Him and I were part of trying to prove to people back in 2005, this is 15 years ago, I'm getting old, and we were trying to prove to people that indeed rainbow trout, steelhead, and Chinook salmon, lived in the Guadalupe River. And so we would capture them, take photos of them, take the length of them, we keep them in water the whole time, and then we would send that information to Valley Water and other organizations, the Department of Fish and Wildlife, and so many organizations. At the time, I was cleaning up the homeless off of the Guadalupe River, which has recently went back to horrible conditions. But at the time, I didn't have one homeless person on that Guadalupe River for miles because of the salmon and trout and the work that we were doing with Department of Fish and Wildlife, with Sounds of Conservation. So many organizations got involved. It was great. Anyhow, beautiful specimen, and that is next to the airport, the San Jose airport right there with that specimen. Next slide. And I have other photos of way larger fish and things, but anyhow. So let's get into some restoration. So we know the fish are here. We know they're not doing well. We know that we're up to 2 million people in Santa Clara County now. We know it's not going to get any better. We know that we have to find, and then we know from David Attenborough that the only way that we're going to make this planet a better planet and sustainable is through restoration and biodiversity. We have to fix the biodiversity that we have ruined or ruining as a human species over the last 100 years. And that is a true fact by David Attenborough and by his lifelong, by what he's seen with his own eyes over the last 100 years. It's a great show. You should actually watch it. And so anyhow, by restoring habitat, restoring biodiversity, we're bringing back biodiversity, and we are making sure that that species is going to continue on regardless of our population growth, right? So anyways, let's look at this and the great groups that are doing things. Okay, so Pescadero Creek. So one of the organizations that I've had the pleasure to work with over the years, and still kind of am the lead trainer for the Monterey Bay Salmon Trout Project, and also some great organizations that are doing things on Pescadero Creek are the Monterey Bay Salmon Trout Project, the San Mateo Resource Conservation District, and Peninsula Open Space Trust. And the work that they're doing is to recover the coho salmon, right, on Pescadero and Butano Creek, right? Because there is a tremendous amount of potential, and there is a tremendous amount of incredible amount of hope. Okay, so next slide. All right, so one of the cool things about Monterey Bay Salmon Trout Project, if you didn't know, right, and one of the cool things that got me excited about this is Kingfisher Flats Hatchery. The Monterey Bay Salmon and Trout Project has one of the only conservation hatcheries in our area, being over near Davenport. We wanted to show you this section of a video really quick so that you understand that indeed there are restoration, there are areas for you to get involved in and volunteer with great organizations such as this. So let's go ahead and watch this because we're pressed on time. So let's watch this.
Hey everyone, welcome to Kingfisher Flat Hatchery here on Big Creek, about a half hour north of Santa Cruz. And this hatchery is actually part of something really exciting, trying to prevent the extinction of a locally adapted species of salmon, the Central California Coast coho salmon. And the work we do here is a little bit different from some of the larger hatcheries, the larger production facilities. The fish we're raising here aren't necessarily to catch, they're to support the wild populations and to try and bring this species back and recover them. So what you're going to see today is actually our fry room where we incubate eggs until they become fry or little baby salmon. And you're also going to see some of the outdoor rearing vessels where we have the fish that are a little bit bigger than that. And you're actually going to get to see us release some of these coho salmon to the wild today to try and, again, support local populations and prevent the extinction of Central Coast coho. So here is Kingfisher Flat, and we'll walk you guys through every piece of the facility and get you to see a release. So what we have here is the moist air incubator. And this is the first place that eggs go once they're spawned out of a female fish. So they're mixed, the eggs and milk are mixed, loaded into the moist air incubator, and then they're sprayed with a fine mist of water that keeps the eggs all nice and cool and wet, just what they want to be. So these little nozzles here coming down the front are actually just like the vegetable misters you see at a supermarket. What they're doing is keeping a pretty constant moisture level on top of these eggs so they stay nice and wet, and then they get to a point where you start to see their actual eyes develop. That's called the eye-up stage, and then they get moved on to the next part, which is the heat incubator. All right, guys, so after the eggs come out of the moist air incubator, and again, once their eyes have developed, they get moved to these things that are called the heat tray stacks. And like you can see, these trays, the heat trays, are just in these stacked columns where they have water flowing down over the top all the time. It's the same idea as the moist air incubator, but instead of like a fine mist spraying on the eggs, there's actual flowing water running over them. So that's what you have to mimic the idea of a stream environment, to set clean, cold flowing water stand all over the eggs at all times. And these eggs will stay inside the heat tray incubators for another month after coming out of the moist air incubator before being moved to the troughs, which you guys are going to see some video and pictures of here in a second. The adult fish that we have here at the hatchery actually eat this, which is Antarctic krill. It's actually caught in Antarctica, and we get it shipped up here on big pallets. And we go through a lot of it to feed all these brood stuff. So I know you guys can't smell right now, but it smells very fishy, very shrimpy. But it's important that we give the fish this high-quality wild food because that's what helps their immune systems develop. It's what helps them grow healthy and strong. Really feeding these fish what they would eat in the wild has been a big part of what makes our hatchery fish successful and healthy.
Girls, my name is Richard Tejeda with the Monterey-based Salmon and Trout Project, and today we are at Kingfisher Flats Fish Hatchery. It's a place where they raise coho salmon. They've been raising coho salmon for a year, and right here is a holding pond where the coho salmon are located. Today is exciting because we get to release these coho salmon into Big Creek so that they can begin their journey down to the Pacific Ocean and one day return back to Big Creek to spawn.
All right, fantastic. So as you can see, if you didn't get excited about that, this science, the biology that's behind that, the partnership between Monterey Bay Salmon Trout Project, NOAA, and other organizations, it is amazing. Monterey Bay Salmon Trout Project has been around for over 50 years. I'm just happy to be a part of that organization and know that the hatchery did burn down and that they are still functioning amongst ashes. So we a call for donations. Anyhow, check them out. Check out their website. Next slide, please. So Peninsula Open Space Trust is doing big things here, right? Because you see, it's about restoration. It's about habitat. You need habitat to fix biodiversity. And here, what they're doing is they're fixing habitat. They're removing barriers and sediment control and erosion control, as well as installation of woody structures. Remember the dynamics of a healthy creek and what a fish needs to survive. And the reason is sediment is so important is because if you look on the picture on the left, you'll see what happens to eggs if there's too much sediment in the river. Remember I said they're permeable. They need oxygen to live, the eggs. And if you smother them with sediment, they can't breathe. They literally suffocate and die. So if you look on the picture on the right, that's the ideal where there's less sediment and the oxygen is moving through the eggs. And there is a little bit of sediment, enough just to cover what's called covering. They're going to cover the eggs so that they don't get eaten by predators, and that when there's a high storm, they don't get washed away. But not enough to they get smothered by a sediment that is due to lack of, riparian corridor or habitat. And so that's one of the things that happens. Next slide. And that's why it's so important to have this restoration. Now, the San Mateo Resource Conservation District are doing big things as well. Like, if you build it, they will come. That is a true story. With the help of partners, the San Mateo Resource Conservation District has demolished concrete dams and modified a road crossing, opening up 62.3 miles of riffles and pools to coho salmon and steelhead trout for spawning and rearing habitat. Again, habitat is so important to fix the biodiversity of these fish and allow them to have a place to come into, not run into the barriers, not run into road crossings, and not have all of these different obstacles to deal with. It's hard enough on them as it is, with only 2 fish out of 2,500 making it back to spawn. We need to do everything we can to help them be successful. Next slide. All right, so this is really cool. So Save by Nature is about partnerships, and we're about because we understand that work in the community is very important, but partnerships are very powerful because we're about uplifting each other. And as you can see here, teamwork makes the dream work. This is where Monterey-based Salmon and Trout Project, Resource Conservation District, and Post all come together. By Post having properties, by the Resource Conservation District having properties, by them restoring these properties, enables the Monterey-based Salmon and Trout Project to have habitat to plant the coho salmon. Because if you can raise the coho salmon all you want, but if you don't have a habitat to plant them in, especially their natal habitat that they've evolved with through hundreds of thousands of years, then it's going to be less successful. So let's watch this.
Today is amazing. To see the moment that they leave the bucket and swim off and become wild creatures. I hope that this helps people feel that they're part of something wonderful and great that goes beyond their built human environment.
Arapachitiahuan wasiahiyam. Arapachitiahuan wasiahiyam. Arapachitiahuan.
Often when people talk about salmon, they talk about the ancestry of salmon, the tradition, the heritage of how it used to be. And what we're doing today is restoring that heritage so that decades, hundreds of years from now, hopefully, the fish that come back into this watershed will be the descendants of the fish that were put in here today.
Coho are a symbol of healthy functioning ecosystems.
Okay.
We have been looking for opportunities to supplement populations where they historically existed. Pescadero is one of those places. We just feel like enough has happened. We feel good about the trajectory of this watershed. We think it can support salmonids. So here we are reintroducing fish.
The reason that fish can survive here is because public and private landowners, farmers and ranchers, environmental advocates, agency staff, all have contributed something at a landscape scale, at a watershed scale, to make it possible for these fish to thrive today. Everyone has a role to play, everybody. There's plenty more to do.
Just a beautiful video. And I wanted to mention that, that the Monterey Bay Salmon Trout Project video of the hatchery was actually in partnership with Monterey Bay Salmon and Trout Project, Saved by Nature, through a grant from NOAA. And it's very important, again, like Kelly X was saying, for us all to work together, including presentations like this, which make people aware of the salmon and trout, but ultimately to get them excited. So love that video. Love how the organizations have worked together. Yes, next slide. Great job by them. And so again, you know, the hatchery at the Monterey Bay Salmon Trout Project recently burned down with the CZU fire. They're working out of tents. They're still making things happen. The Resource Conservation District is still doing great work and still in need of volunteers and donations. And so anyhow, if we want to support groups that are doing great work in the community already, we can support them by volunteering our time, or we can support them by making a donation. Some things that you can do, right? There's so many things, but protect salmon habitat, support local conservation efforts, conserve water and electricity, and reduce CO2 emissions, because that is all connected in water use, as well as in climate change, because the #1 threat to our salmon and trout eggs is water temperature and them even being able to hatch due to climate change. Remember, they need shade, they need cold water, right? Educate yourself about stormwater. There is no little person that lives inside of the drain and the gutter that separates recyclables, that's in there taking the pesticides out. If you spray your garden with pesticide 2 days before it rains, that rain is going to run off into the gutter and right into our streams and creeks and right through the gills of our fish. It also causes hypoxia conditions that reduce the amount of oxygen, right? So be aware of what goes down your gutter. Only water, not even leaves, because leaves need to decompose, and that takes dissolved oxygen as well, okay? Not many people know that. Avoid, and then also put permeable surfaces in if you have. It's a new generation, it's a new era. We don't pave surfaces anymore. We put in permeable surfaces or porous surfaces. The water can permeate into the aquifer, into ground water, get, filtered off before running off, and pollutants, okay? All right. This is so cool, great. All right, perfect. So, and then garden for healthy streams, yes. And then here's the rippling of rivers will not utterly despair of anything. So if you've ever spent time next to a river or creek after having a bad day, it just melts away. It's kind of what this is saying, by Henry David Thoreau. Yes. And thank you. Yes. And so, we finished right on time. We're champs for that. It was a lot of information. Thank you for hanging in there with us. Ultimately, I hope that you're inspired, or at least leave with a better understanding of what lives in our rivers and creeks. So the next time you're looking down at Pescadero Creek off Highway 1, or next time you're in downtown San Jose next to the Shark's Tank looking into the Guadalupe River, you look at it in a different way. Yes, yeah.
That was so amazing, Richard. Thank you. And I have so much more appreciation now. There's so much to this, we could talk about any one of these creeks, San Mateo Creek or Los Gatos Creek or Stevens Creek, so I encourage all of you who are passionate about this topic, who live near a creek or watershed, to figure out how you can get involved too, right?
A great place to see Stevens Creek, and and some interpretive science, a trail walk, and some of the things they're doing there for the steelhead rainbow trout is Blackberry Farm in Cupertino. It's a great place to park. There's a parking lot there, and you can go for a walk along the creek.
That's wonderful. In our follow-up email to everybody who registered, we'll include some links too, to the organizations and initiatives that Richard shared. But I just want to, for the sake of time, just make sure that you all see this URL here. This is Richard's organization, savedbynature.org. You could go there and follow their work. Of course, we encourage you to support Saved by Nature, the Monterey Bay Salmon and Trout Project, all the other organizations, in addition to Post. So we want to say thank you for joining us today. Our next event will be on wildflowers in a couple of weeks, and I know you're doing programming around that too, Richard. It's game time for the wildflower season. So we're going to have California Native Plant Society staff, Andrea Williams, talking about all the native wildflowers of the area, and that will be in a couple of weeks. So
Great.
Yeah, so again, thank you, Richard. Hope you get out to a creek or a stream soon and have a nice weekend. We appreciate you so much.
Absolutely, and I will do. It's a wonderful time right now, and yeah, thank you to Post, and thank you everybody for joining us, and have a wonderful day. Have a wonderful weekend.
All right. See you later.
Get out in nature.
All right. See y'all.